In this video, we're going to compare and contrast the SN1 and SN2 reactions. The SN1 and SN2 reactions are both types of nucleophilic substitution reactions. Remember that in a nucleophilic substitution reaction, a nucleophile, shown here, is going to replace a leaving group, here in blue. The nucleophile is going to be an electron-rich species, and it can be negatively charged, as shown up here, or neutral, as shown down here. A nucleophile that is negatively charged could be something like hydroxide, OH-, and a nucleophile that is neutral would be something like an amine. If the nucleophile is negative, then it will not have a charge in the product. If the nucleophile is neutral, then it will have a positive charge in the product. The leaving group that falls off typically is going to have a negative charge after it falls off. Remember that the best types of leaving groups are weak bases, so something that is a strong base would be a bad leaving group. First, let's look at the SN2 reaction, which we've seen before. In the SN2 reaction, the nucleophile attacks the carbon that the leaving group is attached to. The carbon-leaving group bond then breaks, putting a lone pair on the leaving group. This ends up with the nucleophile attached to the substrate in place of the leaving group, and the leaving group falls off with an extra lone pair, so it is typically negatively charged. This happens all at once, or all in one step. In the SN1 reaction, the leaving group falls off first, as shown here. You end up with a carbocation intermediate, and then the nucleophile will attack. So if we compare it to the SN2 reaction, the SN1 reaction takes two steps. The hint here is in the name. In SN2, the S stands for substitution, the N is nucleophilic, and the 2 is for bimolecular, meaning that two molecules are involved. 1, 2. The SN1 reaction, however, is unimolecular. Only one molecule is involved. Even though the overall effect of these reactions is the same, nucleophile replaces leaving group, the mechanism is very different. Here's an animation that we can look at, and it'll help give us a good idea of how these reactions differ. First, let's take a look at the SN1 reaction, shown here. In the first step of the SN1 reaction, the leaving group falls off. Then, in the second step, the nucleophile comes in. However, if we compare this mechanism to an SN2 reaction, in the SN2 reaction, both things are happening at once. So you can see the leaving group fell off at the same time the nucleophile came in. This cartoon is great for understanding the SN1 and SN2 reaction. The top version here is giving you the idea of an SN1 reaction. You can see gray cat sitting here. Gray cat leaves, and then orange cat steals the bed. In the bottom, though, you can see the SN2 reaction, because what happens is orange cat just kicks gray cat out. So this happens all in one step. An SN1 reaction is a two-step reaction, and so the reaction coordinate diagram is going to look a little different from the one-step reactions that we've seen for the SN2 reaction coordinate diagrams. You can see that what we've done here is we've added a little spot for the intermediate, and that's where the carbocation intermediate is going to be. So there are actually two transition states now and one intermediate. In a one-step reaction, remember, we just had one hump because we didn't have any intermediates. We just had one transition state. Here's the reaction coordinate diagram for an SN1 reaction. And here you can see the reactants on the left. The leaving group falls off to give us the carbocation intermediate. And so you have the intermediates here, and then the products are over here when the nucleophile comes in and bonds to the carbocation. We have a transition state here, and another one right here. Note that the first transition state is higher in energy, so this is going to be the rate-limiting step, or the slow step in the reaction, and we'll talk more about that in just a little bit. For right now, what you want to be able to do is draw mechanisms for the SN1 and SN2 reaction. You also want to be able to match these reactions to their respective reaction coordinate diagrams and label the reaction coordinate diagrams appropriately. In the next video, we're going to look at the stereochemical outcomes of the SN1 and SN2 reactions, and it'll help us to understand why the difference in the mechanism is so important.